Question number 4, modeling data with equations. So think about the growth and the starting point for the simple and compound interest situations. Use this information to model each of these situations with an equation. So we already talked about this a little bit up in question 3 when we were putting our graphs in the y equals and looking at the table. So for my simple interest equation, it's going to be y equals, and it's growing by $80 each time, so it'd be 80x because this is my growth rate. 80x plus my initial amount of money that the account started with, and it started with $1,000. My compound interest equation is going to be y equals my initial amount that was put into the account, $1,000, times my growth ratio, which each year it was growing by 1.08. That'll always be to the x power. So we want to check that each of these equations are correct. So we're going to use our table from problems 1 and 2. What I'm going to do is I'm going to check the 4th year. So I'm going to check that bottom row of the table. So for my simple interest problem, I'm going to put into the equation 80 times 4 plus 1,000, because I want to check if I put in 4 for x, I should get the answer of 1,320 out, which I do, so I know my equation is good to go. For compound interest, we're going to use this equation. Once again, we're going to put in 4 here, and we're going to hope to get that same answer out as what's on the table on the back of this paper. So 1,000 times, or parenthesis 1.08, end parenthesis, to the 4th power. And I do get the answer of 1,360 and 49 cents, which is what I had on my other side of the paper. So we once again know that equation is correct. All right, question C. We're going to use the model to predict how much the original $1,000 investment would be worth at the end of the 20 years in the credit union account. Just a little reminder that the credit union account was for the compound interest. So I've got my equation here, 1,000 times 1.08 to the x power, but if I want to look at the 20 years, I'm going to raise it to the 20th power. So 1,000 parenthesis 1.08 to the 20th power. So therefore, that $1,000 after 20 years becomes $4,660. And it is money, so I'm going to round to 2 decimal places, so 95 cents. And then I look at that 7, the 7's going to round it up to 96 cents. So my investment is worth $4,660.96. Question E, notice there is no question D, but for question E, I want you to put this answer into Socrative. So using my answer from C, I want to know how long is it going to take for my simple interest to make that much money, to make that $4,660.96. So we've got my equation of y equals 80x plus 1,000. And I want to know, when does this equal $4,660.96? So there's 3 ways that you could do this. You can solve this algebraically, solve for x and see what that is. The second way is look at our table and search through the table using this equation to see when the y value is more than $4,660.96. And then a third way is we could guess and check. So you could start plugging in numbers there and just trying to figure out until you get a number that's equal to this or bigger. Because remember, it's okay to be bigger, but it cannot be lower. So when you figure out that answer, go ahead and put that answer into Socrative. Round your x value to the farthest year, the closest year. So you should put the year that it's going to take to get this or more. After you're done with that, go ahead and take out your homework and start working on that for the rest of the period.